Thank you for click on this video. I sajal.sasmal welcome you to complete lecture series of solar photovoltaics. Please click on description for playlist of complete solar cell tutorial. Let's start. Diffusion length in semiconductors. Diffusion length is the average length a carrier moves between generation and recombination. Semiconductor materials that are heavily doped have greater recombination rates and consequently, have shorter diffusion lengths. Higher diffusion lengths are indicative of materials with longer lifetimes and are, therefore, an important quality to consider with semiconductor materials. The second related parameter to recombination rate, the minority carrier diffusion length, is the average distance a carrier can move from point of generation until it recombines. As we shall see in the next chapter, the diffusion length is closely related to the collection probability. The minority carrier lifetime and the diffusion length depend strongly on the type and magnitude of recombination processes in the semiconductor. For many types of silicon solar cells, SRH recombination is the dominant recombination mechanism. The recombination rate will depend on the number of defects present in the material, so that as doping the semiconductor increases the defects in the solar cell. Doping will also increase the rate of SRH recombination. In addition, since Auger recombination is more likely in heavily doped and excited material, the recombination process is itself enhanced as the doping increases. The method used to fabricate the semiconductor wafer and the processing also have a major impact on the diffusion length. Color chart of a high-efficiency multi-crystalline pearl solar cell. The percentage refers to the fraction of light-generated carrier, and the variations between one region and another are due to variations in the diffusion length in the solar cell caused by the grain boundaries in the multi-crystalline material. In silicon, the lifetime can be as high as 1 millisecond. For a single crystalline silicon solar cell, the diffusion length is typically 100 to 300 micrometers. These two parameters give an indication of material quality and suitability for solar cell use. The diffusion length is related to the carrier lifetime by the diffusivity according to the following formula, where L is the diffusion length, D is the diffusivity, and tau is the lifetime in seconds. The diffusivity is a measure of how quickly a group of particles fill a space, and it is described in more detail on the diffusion page. The diffusivity is typically given in square centimeter per second and the lifetime is in seconds, so the above formula will give the diffusion length in cm. However, a diffusion length in a silicon solar cell will typically be quoted in microns, micro-m. Multiply the result by 10,000 to convert from cm to micro-m. Thank you for watching the video. Please like and share this video. I will be so happy if you subscribe my YouTube channel. Click on description for playlist of complete solar cell tutorial.